My name is Robert Cole. Welcome to my presentation on databases in PostgreSQL. With that said, let's start on this. So first off, we'll just go into what are databases. Database is an organized collection of structured information. They're usually written in structured query language, SQL. I'm sure most of us are probably somewhat familiar with that. And usually users access them through database management systems, DBMS. Database management system lets users access their database and manipulate data, report, and represent data. It's also used to help control it. It's basically it's more put together GUI that lets you access your data. And one useful thing with databases is that as of 1997, they actually added XML support to apply to database processing, which is formats you're really familiar with, I'm sure, such as Excel. All right, so then there's a bunch of different types of databases. The first one is a relational database. I'm sure we're familiar with that if you took the SQ or any of the database management classes. That's where you have like the primary key, secondary keys, everything relates and ties into one thing or another. There's no like loose connections, nothing you can't reach through one part. Then there's object-oriented databases where everything's treated as an object. You also have distributed databases, which is where it's in various locations. Data warehouses, and then you get into stuff such as NoSQL, which is pretty much different than a relational database where you have they're non-relational, and they can be unstructured, semi-structured, and stored and manipulated as such. And they're really popular. They're more popular nowadays than relations, as to my understanding, because they're used with stuff such as web applications and distributed systems. Newer one or another one that's also around is a graph database, which stores relational entities and the relationships between them. So a few more types of newer databases. We are seeing the emergence of, or we've seen it of, cloud databases, which those can be either structured or unstructured and just exist within the cloud. There's multi-model databases, which combine some of the past few we talked about: relation, data warehouses, NoSQL ones. Well, not relation, NoSQL usually, but it combines a bunch of different databases. Then you have document/JSON databases. Those are used as databases for documents. So if you have a bunch of PDFs and stuff like that. And then the self-driving databases is one of the newer ones that you're seeing in the markets, and they are more in high demand. Those are the ones that use AI and stuff, so they're considered autonomous databases, cloud-based, and they use machine learning to automate database tuning, backups, and other routines and tasks. Would be really useful in a lot of scenarios. There still exist a lot of jobs. I currently have to do some of them where you have to manually go in and back up these databases and do these maintenance and routines on these. These ones will use AI and various other things to do that themselves. So there's different structured query language variations. Now all SQL is SQL, but there's different ones such as Microsoft SQL Server, MySQL, PostgreSQL, and then SQLite. And then if I just go over to the next slide here, you can actually see some of the variations here. So for instance, it's mostly here in syntax. So if you have a select from column 1, column 2, or versus, and you put these in brackets with SQL Server or Microsoft SQL Server, and here you don't have brackets, and there's just a couple different variations along the way of these kinds of things. It's small syntax error or syntax variations. So if you look at, for instance, if we do this select average colon 1 equals average 1, instead in MySQL you would use as average 1. It just varies slightly from one thing to the next. And I got this from datacamp.com. You can easily just look up the differences. But for our class, we're going to be talking about PostgreSQL. And Postgre is a traditional relationship database management system, and RDBMS is what it's known as. It supports both SQL and JSON querying. It's open source, which is really helpful because that means you don't have to pay as much for that. Well, actually, you don't have to pay at all. And it supports most programming languages. So the ones in particular it supports would be Python, Java, C#, C, C++, Ruby, JavaScript, only with the Node.js, Perl, and Go and TCL. So some of the highlights of this about Postgre is that it's user-defined. It's got table inheritance, sophisticated locking mechanisms to prevent overwriting data or simultaneous access to the data, which could cause errors. Foreign key reference integrity. You got views, rules, subqueries, nested transactions, multi-version concurrency controls, and asynchronous replication. So, and those are just some of the highlights. Some of the more recent things they've added to Postgre would be the native Microsoft Windows support or server support. So that means now you can't just use this on Unix and Linux systems. It also works on Microsoft if you're going to consider that. Most people would just use Microsoft SQL Server, I believe, in that case. But this would be a nice free or a nice open source alternative. It would also probably be more useful for people trying to just pick up SQL. They also added table spaces and point-in-time recovery. And here I've got something called pgadmin 4. I just wanted to throw this in here too because pgadmin 4, it's an open source management system. It's basically the GUI side that you can use with Postgre, and you can see all your various information, your tables, queries, all that stuff from here. You'd be able to see something cool I saw here is you got tuples out, which is a Python element where you are able to pack up data. So it's kind of cool to see be able to see all this stuff. And I can't think of many people that currently work in a system where you only do like select table from XYZ. Usually you're going to have some kind of GUI interface to also work with alongside that. Alright, so then I got the commands here for installing it on Linux. You're just going to do a sudo apt-get install, the apt-get package installer of PostgreSQL. Once it's installed, you're going to go through the configuration files, which is in the /etc/postgre. You're going to insert the version, and then you're going to go to the main file. You can usually just kind of traverse through it. It's probably going to vary from distribution to distribution and like version to version. But it's going to be in the /etc/postgre, and then you can sort of traverse through and see where all the stuff is going to be found. Now, the main thing you're going to want to remember though is the thing ending in a .conf is the config file. So you're going to open that and be able to edit various lines in that script. And you can use service PostgreSQL, do like a help or some command with that, and you'll be able to see the control status. So you'll be able to stop, start the server, and perform various other maintenance on that. So with Postgre, you also want to protect some hardening recommendations. You're going to want to protect from pickling. What pickling is where Python, and there's a lot of other things you're going to want to do, but Python in particular has a thing called pickling, which lets you basically write as data as data streams or bit streams. So you can use write it as ones and zeros, and this means that you can't do data sanitization as stuff enters the server. So you're going to want to find ways to protect from that. It's going to take a little more research to do that. It's pretty difficult. That's a more recent problem with that. You're going to want to disable auto logons as the default user with SQL statements. So you're going to want to do the alter roles Postgre no login. Just put that. You're going to put that command in with a semicolon. It's an SQL statement into the table. And you're going to want to, I put this Go Teleport blog in here just because it's a useful link. It has like a couple other hardening recommendations. You should go through those. And then, but another big one you're going to want to do is create roles, and you can make new roles for each user in there. And with the default user, the Postgres, that's the default like root user basically. You're going to want to make other users besides Postgres, and you can assign permissions to them from there. And then I just went ahead and included some resources here. So I appreciate y'all listening to my presentation here, and y'all have a great day.